Hello, my name is Adrian and today we are solving Math SAT problem, section 7, problem 12. So this is the problem we're working on today, and the equation we're solving. We must solve for x, and to do so we must move all values in the x side to the other side to leave the x alone. And these are the options for the final answer. So the first step is to move the first term to the other side. The first term we are moving is this negative 2. To move that 2, we must add 2 to both sides to cancel this negative 2. So 4 square root of 2x minus 2 plus 2 equals 16 plus 2. You can cancel these two terms and you will be left with 4 square root of 2x equals 18 because you add these two values. The next step, like in the previous step, we must move another term from the x side to the other side to leave the x by itself. So we must move the 4 by dividing both sides by 4. So 4 square root of 2x over 4 equals 18 over 4. As you probably know, if you have like terms in the numerator and denominator, you can cancel them out, and you will be left with square root of 2x equals 18 over 4. The next step is to simplify this fraction, which can be simplified into 9 over 2. So rewrite the problem with a new fraction. So square root of 2x equals 9 over 2. Then you must leave x alone, so you must move another term to the other side. In this case, we can move the 2. Next, however, there's a square root enclosing that problem. So I'm going to get rid of that square root first, and to do so, we square both sides. So square root of 2x squared equals 9 over 2 squared. Then we do the math, and like I said, the square root and the square cancel out, and you will be left with 2x equals, and you distribute the square to both terms. So 9 squared is 81 over 2 squared, which is 4. Next step is to move this 2 to the other side, and since there's no square root closing it anymore, we can divide both sides by 2 to move the x. So like we did in this step, you can cancel these two like terms, and you will be left with x equals 81 over 4 divided by 2. These two can be written as 2 over 1 to make this problem easier, dividing. When you're dividing two fractions, you can multiply the first fraction times the reciprocal of the second one. So let's do that. X equals 81 over 4 times the reciprocal of 2 over 1, which is 1/2. Then you just do the math, which is 81 times 80 times 1 equals 81, and 4 times 2 equals 8. So that is your final answer. So you can't simplify it any further. And we do have that option in the multiple choice, so that is our final answer. Similar problem to this one is the following. 3x over 4 equals 5. Like we did on the first problem, we must move any term farthest away from x to the other side to leave x alone. In this case, we're multiplying 4 to both sides to get rid of that 4 on this side. So times 4 and times 4. So this part can be written as 4 over 1. And like I said before in the previous problem, when you have two similar terms, numerator and denominator, you can cancel them out only if these terms are being multiplied. So you cancel them out, and you'll be left with 3x over 1, or just 3x equals 5 times 4, which is 20. And then you move this 3 over by dividing both sides by 3. So 3x divided by 3 equals 20 over 3. Like I've been saying very commonly, you can cancel these two terms, these two like terms, in a single fraction and you're left with x over 20 over 3. This can't be simplified any further, so that must be your final answer. And to check, you plug in this x value into the initial equation, which is 3x over 4 equals 5. So let's try that. 3x times the value we got, which is 20 over 3 over 4 equals 5. So this 3, like I said, can be written as 3 over 1, and like we did in this step, we cancel out this two terms which are being multiplied, and you'd be left with 20 over 4 equals 5. 20 over 4 can be simplified into 5, so or 5 over 1, and it's equal to 5. So 5 over 1 is equal to 5, so this final value, this final answer we got in this step is correct, because we plugged in the value into the initial equation, and we got both sides equal to 5. Thank you.